Hello everyone, I'm Luis Labimov. I would like to present our paper, which start the construction of statistical recognition algorithms based on two-dimensional threshold functions. Nowadays, there are many well-known methods and algorithms for solving the recognition problem. However, these methods are mildly aimed at solving such problems where objects are described by a set of independent features. A large number of features describe recognition problems in various fields of human activity. In such problems, the probability of violating the assumption of the feature independence is quite high, and this determines the relevance of these studies. The proposed study is developed model of recognition algorithm based on the methods of making statistical decisions, taking into account the high dimension of feature space. Development of pattern recognition is divided in two periods. In the first period, recognition algorithms were studied, each of which focused on solving certain applied problem of pattern recognition. In the second period, the appearance of research in this field of pattern recognition changed somewhat, and theoretical requisite was a creating number of models of recognition algorithms, units of algorithms for unified description of methods for solving classification problems. At the present, there are quite a few models of recognition algorithms developed within the framework of various approaches. For instance, separations, mathematical statistics, mathematical logic, and voting. However, the analysis shows that the existing model of recognition algorithms are focused on solving problems where objects are mildly described in the feature space of small dimensionality. In practice, there arises a problem of classifying objects defined in the high dimension of feature space. In the solving such problems, the assumption of the feature independence is often not fulfilled. Therefore, development of recognition algorithms that can be applied to solve in high dimension of feature space is not well studied. The aim of this study is the development of statistical model of recognition algorithms based on the construction of the two-dimensional threshold rules. Consider a set of admissible objects T, which consist of disjoint subsets. To clarify the concept training information, we select M object from set of admissible objects T. Let us introduce the following notation for objects. Then the training information, it can be defined as some set of admissible objects whose elements are pairs, where SU is the admissible objects and alpha dash is the information vector of object SU. Let an arbitrary set of objects S-Q described in the feature space X be given. The problem is construct such as an algorithms A, Z, given IT, and S-Q calculates values of predicates P. In this study, we consider statistical approach to solving problem. On the base approach, a family of statistical recognition algorithms based on two-dimensional threshold function is proposed. The task of these recognition algorithms includes following main stages. In the first stage, a system of independent feature subsets is determined. In the second stage, a set of representative features is formed, each of which is typically representative of selected subset of closely coupled features. In the third stage, the function is that characterized similar to object SP and S is in two-dimensional subspace of representative features D. Then, using equation series, the threshold rules defined in two-dimensional subspace of representative features DU are determined as follows. In fourth stage, probability estimate is determined for each class in two-dimensional subspace of representative features. In the fifth stage, groups of strong coupled TTR are separated. It is assumed some TTR can give similar approximate estimate for all objects belong to set C-M. In seventh stage, independent subset of closely coupled reference two-dimensional threshold functions are determined, constructed from all base objects in n-dimensional space R'. In eighth stage, the base two-dimensional threshold functions are determined. In ninth stage, membership estimate of object S to class Kj is calculated for all basic threshold functions. In 10th stage, decision rule is set in which decision on object's membership in one or another class is made sequentially using following equation. Thus, we have defined class of recognition algorithm based on two-dimensional threshold function. Any algorithms A from this model is completely determined by set of parameter P dash. An experimental study to assess the performance of proposed model of recognition algorithms was conducted in solving a number of problems. It's known that one of most developed model of recognition algorithms and having great similarity in concept are model of recognition algorithms based on calculation estimates. This explains our choice of classical model of recognition algorithms based on calculation of estimates A1 to compare the results of experimental study to assess performance of proposed model of recognition algorithms. In this case, following indexes are evaluated and recognition accuracy, the time spent in training process, and the time spent in process of recognizing all objects of test sets. As a practical example, consider the problem of recognizing person's identity from signature images. The obtained result is shown in table 2. As a result of this experimental study, the following recognition results were obtained using proposed algorithms. The error in the training process was 2.7%, and another error in the control process was 5.1%. The results of this computational experiment in solving the problem of identifying person from signature image showed that the model of proposed algorithms provide higher accuracy compared to traditional recognition algorithms. At the present, in many applied recognition problems, the objects under consideration are specified in the high dimensionality of feature space. In this case, the probability of violating the assumption of feature independence is quite high. Therefore, the solution to pattern recognition problem under condition of high dimensionality of feature space is associated with significant computational costs. In this study, a new approach was proposed for constructing model of recognition algorithms, and on the basis of this approach, two-dimensional threshold function-based model of recognition algorithm was developed. The main idea of proposed model of recognition algorithm is determining set of pattern recognition and form based of two-dimensional threshold function on their basis. In order to assess the probability of the developed model of statistical recognition algorithm, experimental studies were conducted to solve the model problem where initial data was scanned according to certain characteristics. The problem of recognizing person identity from signature image. The results of experimental studies have shown that the proposed model of recognition algorithm improves accuracy in solving the problem of classifying objects under the condition of high dimensionality of feature space. Besides, it significantly reduces volume of computational operation for recognition objects in test sets. It should be noted that this model of recognition algorithm is used in case where there is some dependence between the features. Otherwise, if this dependence is vaguely expressed, it is necessary to use classical model of recognition algorithms. Thank you for your attention.